We're going to talk about symmetry. There's different types of symmetry. There's line symmetry, there's rotational symmetry. It's just the idea of symmetry is that it will map itself. It looks like it didn't change. So if you do the reflection or the rotation or whatever, it looks like it didn't change. It looks the exact same. I like to think butterflies kind of have line symmetry. If you fold them, their wings up, their wings match up, that's got line symmetry. If you squirt a bunch of paint on a piece of paper, like you probably did in kindergarten, you fold it up, the paint's going to match on both sides. It's got line symmetry on that fold. So that's line symmetry. So when it maps the figure onto itself. And line symmetry is like reflections, like we were talking about with folding a paper or looking at a butterfly along its body. That would be line symmetry. So looking at this triangle down here, we have the two angles down here that match up. The two sides match up. Remember, these tick marks mean those sides are the same length. So we can sketch in some lines of symmetry. If you fold it right down the middle, vertically, everything matches up. It will fold perfectly over that line. It's the same on both sides of the line. And that's the only one, so it only has one line of symmetry. So for these three figures, we're going to do the same thing. You can always look for a vertical line of symmetry, which this one has, the rectangle has. It also has a horizontal line of symmetry. If you went sideways through this figure, it would match up also. You can check diagonally. Doesn't look like this one would work out if you go diagonal, though. From corner to corner, not quite. So this has two lines of symmetry, one vertical, one horizontal. For this next triangle, could we fold it that way? No. Can't go straight down. Ooh, maybe. I think it's almost, but not quite with that one. I don't think it quite works. Can go the other way? Nope. So we had one that was close, but I think it was just barely off, so there's no lines of symmetry there. For this kind of L, can't fold it that way because then the bottom's all messed up. There's no way it's going to go any vertical lines of symmetry. Check horizontally. No, nothing's going to match up there. Can we go diagonal? Think so. Does that look right? I think so. If you really wanted to get precise about this, you could check to see if the lengths are the exact same. So there's how far it goes from the bottom to the side. And if you turn it sideways, yeah, I think that's the same. It's got one line of symmetry if you fold it diagonal like that. So there's also rotational symmetry. If you pick a point in the middle and you kind of spin the shape or rotate the shape, keeping that point still, it maps onto itself. It looks the exact same. So for this star shape, if you were to hold the middle of that star and rotate it, it would all match up. Now, the harder part is figuring out how many degrees you would have to rotate it. It's kind of a simple math problem, though. Since there's the 5 points, that means it would take, you could rotate it 5 times that it would match up before you go all the way around. So you just have to take however many times you would rotate it, 5 in this case because there's 5 points, and you just divide 360, which is one complete rotation, 360 degrees, divided by 5, and that's how you get to 72 degrees. So it's like every 72 degrees, it'll match back up. So if you rotate it 72 degrees, that point would end up at the top. If you rotate it another 72 degrees, which would be 144, the second point will be up at the top. Another 72 degrees, which would be 216 total. You just keep adding 72. We back up, this next point will be up top, and then 288 degrees would take that point all the way around. And then obviously if you rotate 360, it will be back to itself because you didn't do anything. So we can describe the symmetry. We're going to draw lines of symmetry and the angles of rotation. So if we start with the lines of symmetry for this, I think we can go straight up and down. Can also go horizontally. What about that line right there? And I think there's one more then. So there are 4 lines of symmetry. And the key for the lines of symmetry is you're always looking at the points or the corners of the shape. So it's always going to involve a corner. Now, we also have to figure out the degrees of rotation. So if you look at it, there's 4 points that you can get matched up. There's the top, the right, the bottom, and the left. So each time that would rotate around, it would map onto itself, so it would have rotational symmetry. Since that has 4 points that we're interested in, you take 360 degrees, divided by 4, and that's 90 degrees. So 90 degrees will be the first rotation. If you add another 90 degrees, it'll be 180 degrees rotation, and that would map the bottom point up to the top. And then finally, we could add 90 degrees one more time, and that would map this point on the left all the way around up to the top. And then the last would be 360, but that's not really doing anything, so we're not going to write 360 degrees. There's 4 lines of symmetry and 90 degrees, 180 degrees, 270 degrees for rotational symmetry. So now we'll look at this next figure. Remember, this key for line symmetry is you're looking at the points or the vertices. So if we go from the top vertex down through this little bottom point, yes, that matches up. We can do the same thing from the other points. And all of those are lines of symmetry. So there's 3 lines of symmetry. And then for our degrees of rotation, yeah, it looks that if we spin this around, if we turn it, it will map onto itself. There are 3 points that we're interested that will match up. These 3 points will match up if we rotate it around. We're going to take the 360 degrees divided by those 3 points we just identified. And that means every 120 degrees it will map onto itself. So 120 degrees, and if you did 120 degrees again, we would get 240 degrees. And if you did it again, you'd be up to 360. We don't need to write that. So there's 120 degree rotation, 240 degree rotation, and 3 lines of symmetry. More examples real quick. So to draw the lines of symmetry first, we can go from vertex to vertex and sideways vertex to vertex horizontally. Now, we can also go right down the middle of these straight sides. That would also work, as would that line. So there's 4 lines of symmetry, and then to identify the vertices, so you can see what would match up when we rotate it. There's those 4 corners, the 4 points, which means we would take 360 degrees divided by those 4 points we just identified, and that's 90 degree rotation. Another 90 would be 180. Another 90 would be 270. And the 4 lines of symmetry that we identified. And this last figure, that looks to be the only line of symmetry. And since none of the points really match up, we can't rotate it because it's way longer going left and right than it is vertically. So it will not match up if we rotate it. So there's only 1 line of symmetry and no rotational symmetry.